Hello, geometry students. Mr. Zacek back and better than ever. We are doing a little review of solving by completing the square. Now, this was a big topic in algebra. And why do we want to use completing the square? One reason is it's a method that allows us to solve quadratic equations. And the second is later on in the year, when we are writing equations of circles, it's going to be an essential component of us being able to write the equation of a circle. So that's one of the reasons why it's emphasized in algebra. So we've got some steps written out here for you, and normally, and some of you might be able, you remember this and you'll be able to do this on your own, but for others of you, I thought it would be helpful to make a video for this and just kind of, see it perhaps in a little more detail going through. Okay, so we want to get the variable on one side and the numbers on the other. That's our first step. So I'm going to subtract 7 here from both sides. And I'm going to do x squared plus 10x equals 18. Now, step 2 says factor out the a term if it is not 1. So the a term is the number in front of x squared, and in this case, it is 1. So we don't really have to do anything there. I'm just going to rewrite that again. So x squared plus 10x. I'm going to leave a little space here and 4. Did I write 18? That should be 4. So I like to call this, now we gotta add something to both sides. And I'd say, what the blank are we adding on here? Well, we want to add something that's going to make the left side what's known as a perfect square trinomial. And the way that we do that is we take the value of b, which is 10, we divide it by 2, and we square it. But our rules for equations say that in order for it to be balanced, whatever we do to one side, we have to do to the other side. So 10 divided by 2 is 5, 5 squared is 25. So in essence, we are adding 25 to both sides. Now, what we've done is we've created, this is what's known as a perfect square trinomial. And the reason why we want to write it as a perfect square trinomial is so that we can rewrite it, which is step 7, as a binomial squared. A binomial has 2 terms. And the way we do that is we take x plus b divided by 2. Our value of b is 10 divided by 2, and that's the whole quantity of that is squared. So it's going to equal 29. So this was really x plus 5 squared equals 29. So we can kind of think of that binomial as like the square root of the perfect square trinomial. Okay, so once we get it to this point, it's a matter of solving this equation. So x plus 5 quantity squared equals 29. So how are we going to do that? We're going to take the square root of both sides. And when we take the square root here, it's going to cancel out the square. One key point we have to remember to do the plus or minus, because there's a positive and negative square root here. And now we're going to subtract 5 from both sides. And I'm just going to kind of squeeze it in here in front of the plus or minus. So it's negative 5 plus or minus the square root of 29. All right, and so that is our answer. We could leave it like that. We could write it as separately, negative 5 plus the square root of 29, or x equals negative 5 minus the square root of 29. And if it said round to the nearest tenth or something like that, we could also go ahead and do that. All right, so that is completing the square. All right, let's do a couple more. 2 is very similar to 1, and then 3 has some things we have to consider as well. So first thing we're going to do is we're going to isolate the variables, and we're going to add 4. So we're going to get x squared plus 6x. Now I'm going to leave a little blank here, equals 16. All right, so we got to add our blank to both sides. and our blank is going to be b divided by 2 squared. B divided by 2 squared. So 6 divided by 2 squared is 9. And over here, we're going to get 16 plus 9. Okay, so again, this is our perfect square trinomial. And the way we're going to simplify that is x plus b divided by 2. B is positive 6 divided by 2 is 3. Quantity squared equals 25. So now we take the square root of both sides. We get x plus 3 equals plus or minus the square root of 25. So I'm going to subtract 3. And again, I'm going to kind of sneak it up in front of that square root. It's going to be negative 3 plus or minus. Now 25 is a perfect square, so that square root is 5. So this will be x equals negative 3 plus 5, or x equals negative 3 minus 5. So x would equal 2, or x would equal negative 8. Okay, so that's a question we probably could have factored. We could have quadratic formula, but right now we're focusing on solving this by completing the square. Okay, this one is a little bit different and a little trickier because the value of a is not 1, but our starting point is going to start out the same. We're going to subtract 7, so we get 2x squared plus 8x equals 4. Now here's where it's different is we want to factor out the value of a. So we're going to divide both of these by 2, so it's 2 times x squared plus 4x. Okay, so we factored out that 2, and now I'm going to divide both sides by 2, and those 2's will cancel out here. We'll be left with x squared plus 4x. I'm going to add my blank in at this point, equals 2. Okay, and so what are we going to add? What the blank are we going to add here? It's going to be 4 divided by 2 squared. Okay, 4 divided by 2 squared. So this is going to be x squared plus 4x plus 4 equals 2 plus 4. All right, so we've got it as a perfect square trinomial. We can rewrite it as x plus 2 squared equals 6. So x plus 2 equals plus or minus the square root of 6. We're going to subtract 2. X equals negative 2 plus or minus the square root of 6. And at that point, we could, simplify accordingly based on how it was asking us, to solve it there. So completing the square, another method, a third method for solving quadratics, but will also become very important later on when we're writing the equations of circles. Okay, so if you need any clarification on that, please ask, and I'll see you soon. The next video will be jumping into lesson 1 of unit 7. So a little preview work, little review work, I guess I should say, to get things going, and now we'll be jumping in. All right, see you soon.